Okay, today's lesson is A98. It's function notation. What's our objective class? Get ready?
Function notation.
Function notation. So yesterday we learned how to determine whether or not a function is a function by looking at it. We did the vertical line test. We looked at the table of values. Today we're going to learn how to write a function and how to solve a function. And it's pretty similar to what we've done, but there's a new thing that will be new for you. Fernando manufactures crayons. He's got a machine that produces 12 crayons for every block. So picture he's got like this blue block of wax, and he puts it into the machine. Keep going. All right. Oh, thank you. Thank you. He's got this blue block of wax, and he puts it into the machine, and then the machine outputs 12 blue crayons. And then he puts a red block in, and it puts out 12 red crayons. So the rule is 12 crayons for every block. So if he puts 2 blocks in, he's going to get 24 crayons. If he puts 3 blocks in, he gets 36. So his machine has a rule, and it's a function machine. The rule is 1 block is 12. So this is kind of a new way of writing it that you've never seen before. To me, it's super normal and feels comfortable, but to you, it might feel uncomfortable for a bit. This says a function with 1 as the input has 12 as the output. A function where 2 is the input, the output is 24. A function where 3 is the input, the output is 36. So this f with a parenthesis in 1, it's called function notation, and we say f of 1. How do we say it? Get ready?
F of 1.
F of 1 is short for a function of 1 as the input. It's just a shortcut way of saying f of 1. So his general rule, he figures out, is it's 12 times the number of blocks of wax he puts in the machine. He says, so my function, as however many blocks I put in, my output is 12 times my input. So we say f of x equals 12x. How do I say it? Get ready?
F of x equals 12x.
Very good. So again, it's f of x. It doesn't mean f times x. Normally parentheses mean that, right? But in this special notation, we say f of x. Kaylee.
Doesn't all mean times though?
It does, but in this case, it's not. It's saying a function where x is our variable. Okay? A function where x is our variable. It's just like y equals 12x, but it's a new way of writing, and you're going to see this a lot in high school. And if you go into college, you'll see this type of notation there too. So the f of x replaces a y. Why? Why would we do that? This is kind of cool. Take a function like this. This is a relation of numbers. If I said, hey, what is this function if I put as the input a 1? Well, f of 1 would mean 1 squared plus 6 times 1 plus 9. 1 plus 6 is 7, plus 9 is 16. Well, what would be my function if I put 2 as the input? Okay, that would be 2 squared, gauge, plus 6 times 2 plus 9, gauge. 2 squared plus 6 times 2, this would be 4 plus 12, that's 16, plus 9 is 25. And I can figure out, okay, f of 3, if 3 is my input, I would go 3 squared plus 6 times 3 plus 9. You want to see what I'm doing? X is my input. So whatever number there, I substituted in for x. 9, 18, 27, 36. So that's one cool way. If we write it that way, I can go, what was 16? Oh yeah, that's when I put 1 as my input. What was 25? That's when I put 2 as my input. So it's just a way to show it, a way to write it. All right, so in this table right here, this was our crayons table. The rule is the function of x, or f of x, equals 12 times x, the input. So the input times 12 is 36. The input times 12 would be what? Think. Get ready?
48.
48. So we put the 4 right there. How about 5? Emma?
Hold on.
I'll come back. Rachel? I'll come back. Sophie? Very good. So what's my rule here? Layla? What's my output is what I mean. 72. Very good. So you can just do this 6 times 12, or 5 times 12, 4 times 12. Or you can go, oh yeah, it's add 12, add 12, add 12. All right, so I'm going to skip the graph. I think we already know how the graph input output. It's the same as normal. This would be your x-axis. This is your y-axis. This is your output. But the fun part is when we get to evaluate functions for different inputs. So here's an f of x function. The rule is 2 times the input minus 4. That's the rule. It says find the function evaluated at 3. In other words, if you input 3, what's your output? So I write f of 3 equals 2 times, here's my input, 3 minus 4, and I just solved that. That'd be 6 minus 4, which equals 2. So f of 3 equals 2. How could I find f of 10? Let me call on someone. How would I find f of 10? Jasmine. How would I find f of 10? Let me just get some help. Colin.
So you do 2 times 10 minus 4.
Excellent. So in other words, you put your input right here. So 10 is my input. I put 10 right there. 2 times 10 would be 20. 20 minus 4 is 16. How would I do f of negative 3? Hannah.
2 times negative 3 minus 4.
Perfect. 2 times negative 3 minus 4. So that's going to give me negative 6. Maybe I'll just write it underneath right there. Negative 6 minus the 4, which equals what? Weston?
What? I can't see.
It's negative 6 minus 4. It's like right behind 3 heads.
Negative 10.
Negative 10. Very good. Perfect. All right, any questions? All right, now it's your turn. Functions don't have to just have an f. They can be g of x, can be h of x. Those are the most common, f, g, and h. You can have L of x, M of x, N of x, but f and g are most common. So g of x, here's your rule. Take your input, make it negative, then add 2. I would like you to find g of 0, g of 2, and g of 100. As soon as you've found all 3, put your pencil in the air. Okay, so let's see. I gave everyone most of the time that we needed. I think everyone finished, and I saw mostly right answers. Let's just check. Holden, how did you do the first one?
I just substituted 0 in for x, which would just be 0 plus 2.
So negative 0 really is 0, huh? It's just still 0. So equals 2. Good. Okay, g of 2. How did you do g of 2? Liesel.
I did g of 2 equals negative 2 plus 2, because I substitute the negative 2 in for 0,
Perfect.
and for x, and I got 0.
Got 0. Excellent. And then our last one, g of 100. How did you do that one? Spencer.
So what I did is I put the 100 in the place of the x, which makes it negative 100, and then plus 2 gets you negative 98.
Negative 98. Awesome. I love that almost all of you had your negative figured out, that we're like way down there on the number line, but we're going to come back 2 units, so we're negative 98. Perfect. That's it for evaluating functions. Any questions? There is another problem, but it's the same as what we've already done. So we're going to go right to the practice at page 18. Take a stand-up break for 20 seconds.